Hey guys, welcome to Chemistry with me. And today we are going to make a homemade battery. So let's see if it works. In front of me I have an orange, and in my orange I have some aluminum sticking out of it. I'm also going to take my copper here and shove it into the orange as well. So right now, believe it or not, this could be a battery. The way we could tell if it's a battery is to attach a voltmeter to it and see if we have any voltage coming off of it. So here I have a voltmeter, and I stole it from Mr. Rayo. Don't tell him. And so we're going to just see if we have voltage. And I'm going to hook up. You'll notice I have a black wire and I have a red wire. This is kind of like the same idea as, your car battery, if you've ever had to jump a car before. Most likely you haven't, and yes, I feel old, saying that. I would suggest, though, that you learn how to jump a car before you ever drive one, because it's really good to know. It's very easy to kill a car battery. I know, like, newer cars have like fancier methods of telling you that your battery is dying, or it just like warns you that you've left your lights on. But it's just like a very basic thing to know how to jump your own car battery. And I always have car jumpers, like the jumper cables, in my car, and I've helped a ton of people, and I've also asked a ton of people to help me, because my car didn't have like a beeping sound when I left my lights on. Okay, end of rant. Learn how to do like some basic things with cars before you drive them so that you don't get stranded somewhere. Okay, even if you have help like the AAA, you should still learn how to do it for yourself. Alright, serious end of rant. So I'm going to hook up the black wire to one of the electrodes and the red wire to the other electrode. If I have the wrong wire hooked up to the wrong electrode, it's not a huge deal. All that will happen is that I will get a negative voltage instead of a positive voltage, which is, then I'll just switch them, because I'm not looking at table J, I'm not looking at who's being oxidized, so I don't know what side is the negative side and what side is the positive side. And it's not giving me enough voltage where it's going to be like crazy if I do it the wrong one. So we're just gonna go for it, okay? So here is my voltmeter, and again I have the black one hooked up. So I'm just gonna put my positive side and touch it to the aluminum metal and see if we get a voltage. Oh, we get a negative voltage, which means I have them backwards. So this guy needs to be hooked up to that wire, and this one will be hooked up to the copper. Alright, so let's see. This should give us a positive voltage, and it does! Only for a split second, and like the smallest voltage ever. Really, really barely even a voltage. So yeah, this is like the world's worst battery right here. Oops. But it is a battery because we were able to get some voltage off of that. So go us. What I'm going to do now is I'm going to just switch metals. And I am going to use iron instead of aluminum and see if that makes a difference. I'm just going to, my iron wire is really skinny. I'm just going to stick it in. Alright. So let's see. Hook my negative electrode up, and let's see if we get a voltage from the positive one. It looks like we also get a voltage. This one doesn't look to be as much as when, so this is iron with copper. The last one was aluminum with copper. It looks like aluminum with copper gives a stronger voltage, although that was like a pretty big swing right there. We'll have to check our reduction potentials to see for certain if which one we would expect to get more voltage from. Okay, the last combination I'm going to try is I'm going to use my iron wire, but with aluminum instead of copper. And let's see. Again, I don't know for sure which one is the negative electrode yet, so we're going to just try it this way. So this doesn't look like it's moving very much at all. I can't even tell if it's swinging negative or positive. So they must be too close in reduction potential for this to really be an effective battery. So aluminum and iron, I expect them to be closer together on table J. I could be wrong, but that's what I would expect. Okay, we're now going to try a potato battery because, I mean, you've probably heard of potato batteries before, so let's try it. The difference between using a potato and an orange is really just kind of like changing the salt bridge. We're using the potato and orange as the means for transferring ions. So which one does it better is, you know, it's an experiment. I don't actually know which one does it better. So we're going to see, using the same two metals that we started with for the orange battery, which is the aluminum and the copper, we're going to see if we get a change from this, but with our potato. So let's see. It looks like we do. Again, not a huge change. This is also a really bad battery, but there definitely is a change. It jumps up for a second. This would literally power nothing, but it does give some voltage, which is, you know, what I care about. Okay, I'm gonna again do copper with our iron wire and see if that still makes a change as it did last time. This time it's, I think, harder to tell. I think it worked better with the orange. I don't really see, maybe it's because I'm touching it. Nope, I wasn't grounding it. It doesn't seem to change. So, potato might not be as good of a battery as orange. Okay, the last combination we're going to try. Last time our iron and aluminum did not work very well. We're going to see if it works better in our potato battery. So, let's see. Still no change, if any. So I'm gonna say no. These guys are not a good combination to make electricity. So there we have it, folk. We made some homemade batteries using oranges and potatoes. It seemed like the orange might have worked a little bit better, but like not a huge difference. As I said several times, they're both really, really bad batteries. If you actually wanted to power something, this would not work. I also stole from Mr. Rayo a relative conductivity probe, and this is just like, they have electrodes and it just sees whether electricity is conducting well through it. And you just push the button. I have no idea how this works, but I was like, I wonder if it works. And I push the button, and I see no change on my screen for that. And then I was like, okay, fine, let's try the orange. And I put my relative conductivity probe in there, and I see nothing. Well, then I was like, you know what? Okay, this is old, you know, JIO equipment, not always the newest. Sorry, school. But I was like, you know what? Let's try the outlet and see if that works. Oh, it worked. I can still smell the plastic or whatever inside of here was burning. My roommates want to kill me. It's okay. So yeah, basically your potato and orange battery are really bad. But the cool part is that it does work to a very, very small extent. And so yeah, the key thing is that you need to have two different metals, and one will be oxidized and one will be reduced, and that is how you will get your electricity. Sorry, Mike. So your electrons will be transferred from one of the metals to the other metal. And that's it.